Hello and welcome to Dakota Prep's video tutorial for voltage drop. We have this question here that deals with voltage drop. It says determine the voltage drop percentage for a 100 amp 208 volt single phase load supplied by number 2 AWD THHN copper conductors with a K factor of 12.9 at a distance from 150 feet from the source. Okay, so voltage drop is not it's not difficult, right? We're just plugging numbers into a formula. I do want to point out about this question, though. This is not a realistic question. Okay, I can see by, the number twos here, first of all, the only way this likely means we have a 100 amp circuit, right? It's not going to be loaded all the way up. That's based off of the number twos. It's not going to be loaded all the way to the 100 amps. You don't use the rating of the breaker. You use the actual load. If you have no load, then you have no voltage drop. Okay, so this is going to be a little bit of an unrealistic type of question, but likely the type of question you would get on the state test, even though it is a little unrealistic. Either way, super easy, no big deal. Your voltage drop formula looks like this for a single phase load. This is a single phase. It is 2 kil over C mil, right? 2 kil over C mil, or 2 for single phase times your specific resistance times your current times your length in feet over your circular mil area of your conductor. If it were 3 phase, no big deal. The only difference is it would be the square root of 3, or 1.732 kil over C mil. Square root of 3 instead of 2. 2 conductors, that's why it's 2, or 3-phase stuff, 3-phase system, or phases, or 120 degrees out of phase. That's why the 1.732 versus the 2. Either way, we don't care about that. We just need to plug our numbers into our formula here. So 2 is 2 is 2, that never changes. K, in this case, that's uncoated copper, would be 12.9. I times I, which in this case, all they give us is 100 amp. That's all we have to go off of. We're going to go ahead and plug that in. Our length in feet is 150. Okay, times 150 divided by the circular mil area for number 2 AWG copper. Okay, well, to find that, we need to go to Chapter 9. Chapter 9, we'll write it over here. Chapter 9 of the National Electric Code, Table 8. And in the circular mil column, we roll down till we get to number 2, AWG copper, and it tells us that our circular mil area is 66,360 circular mils. Okay, so now all we have to do, plug this into our calculator. And 2 times 12.9 times 100 times 150 divided by all of that, divided by 66,360 gives us a voltage drop of 5.83 volts. Voltage drop equals 5.83 volts. Okay, so to find that percentage, right, it says determine the voltage drop percentage. All we need to do is divide that by our single phase voltage, which in this case is 208 volts. Hey, what percentage of 5.83 volts, what percentage of 208 volts is 5.83 volts? We plug that into our calculator just as it's written. It tells us 5.83 divided by 208 equals 0.028 times 100%, which means we move the decimal twice. Boom, boom. That gives us a voltage drop percentage of 2.8%, which is less than 3%, which is not required. It is in the informational notes found in 210.19 and 215.2. it is recommended.